Hello, my name is Matthew Hall, and this is my lab report for Lab 1. To introduce this project, our main purpose is to use tape, and this will help us approximate how excess charge can be transferred. We're going to do that by quickly removing pieces of tape from each other, and the hope is that there's going to be some transfer of charge away from the piece of tape, from the upper piece of tape, and it will either attract or repel against a neutral body and or another piece of tape that's gone through the same process. The main principles that we're using are Coulomb's law, which shows that electric force is proportional to the constant, and then both charges, and then inversely proportional to the distance squared. And in this project, we are assuming that the charges are equal to each other, and also Newton's law, which shows that forces are opposite and equal, and so that the sum of forces in this case is zero because we're dealing with motionless objects. And so in this instance, electrical force is equal to gravitational force, which we know gravity to be mass times acceleration due to gravity. And we're using two constants. The K constant is 9 times 10 to the ninth, and the constant for electrical charge is 1.6 times 10 to the negative 19. So for this lab, we're using a couple different materials, and so with these materials, we're going to measure out a piece of tape, and that length is going to be about 20 centimeters. That is about 0.0002 kilograms. And so when we weigh these two pieces of tape together in the experiment, one of them is going to be repelled by the other in way of an electrical force, and so the approximate distance between them in which the electrical force comes into play is about 2.5 centimeters. It's important to note the assumptions. So air resistance is negligible. Even though we're dealing with gravity and we're dealing with all of these forces against the piece of tape, we're not going to consider them in this case. Additionally, the tape is considered to be a concentrated point charge, so the repelling and attraction, it'll all be due to a centralized point, and then gravity is also acting on that same center of mass. And additionally, the charge is evenly distributed. That's why we have this effect. And so some of the results that we expect, it's the charge of the tape ends up being attracted to neutral bodies. If you use two pieces of tape in this experiment, they end up repelling each other because they're induced by the same charge. And the magnitude of the gravitational force, m times g, is equal to about 1.96 times 10 to the negative third newtons. Because of the way this experiment plays out, the electric force of this floating object is the same, and that's because of the principles we learned earlier, where sum of all forces is equal to zero, and so electric force equals the force of gravity. Additionally, the electrical charge we can calculate using this same principle that they are equal to each other, and so by breaking down the formulas, solving for the Q charge, we get that the charge of the piece of tape is equal to 1.17 times 10 to the negative 8 coulombs. And so you can use that to find the amount of electrons on the piece of tape by taking this charge, dividing it by the electrical constant, and getting 7.3 times 10 to the 10 electrons. As the two atoms grow steadily closer to each other, assuming that gravity maintains the same value, at some point the electrical force will start to grow and will end up being at its maximum. And once the arrows, so once the electrical force going upwards and the gravitational force going downwards, once they're equivalent, then we know charge is close enough and we are in equilibrium. And so that's kind of highlighted in a section of the glow script where this simulation takes place. And so some of the final questions that we can look at is, if the electrons and protons switch charges, would that matter? And no, it would not, because the law of attraction and Coulomb's law still apply. Like charges will still repel and opposite charges will still attract, so that doesn't change. And then why is it important that these charges are not compromised in any fashion? It's because you don't want your tape to become neutralized. if it comes in contact with your body too many times, your body is essentially an escape route for this excess of electrons that's being accumulated in this process. The tape is not going to hold all this excess negative charge that we want it to. Thank you.